Hello and welcome to the next video. This time we are going to be talking about functions in Python. Functions are sections of code that you can use repeatedly, so it's something that you would do often, or at least more than once in your program. You define that piece of code and then you point to that piece of code again effectively, and you're saying I want to use that part over and over and over again. So the reason that this is a useful exercise is because it saves you time. You only have to write something once. It saves you space. You're only having to write something once. And both of those combined mean that the code is much more readable. So when you're in your main program, if you have a very good descriptive function name, it means that it's much easier to figure out what's going on than having to go to that really deep level of line by line and having to group it all together each time by yourself. So this is what a function looks like. The first thing is that we have def at the beginning. So def is short for definition. We then have some kind of meaningful function name. And then we have some parameters that are attached to that. So these are variables or pieces of information that you're going to make use of within the body of the function. The semicolon at the end, that defines the scope. So everything that's after the semicolon and indented underneath, that will be the entirety of your function. Once we get to the end of the indentation, we'll carry on with the rest of the program in a similar way to an if statement, for example. And then we have a return. So the very thing at the end of a function is to return something. Now, if you don't have anything that you want to return back to the main function of your program. So for example, you give it two parameters, which are two numbers. You ask the function to add them together and then return the total to the main program. If you don't have something to return back, then the function will automatically send none. So like a null value effectively. So it will send none back to the program. And so if you don't see a return value, it's always sending something, it's just that it's nothing, it's none. And all of that section in the top row is the function header. So if you hear someone reference the function header, they mean the definition of the function name and the parameters within it, with that semicolon to specify that everything within is within the scope of that function header. Now you've seen some of these already. You maybe just didn't know they were called functions yet, but you've seen the print function, for example. You've seen hello world going in there. So hello world is the argument that I'm sending to the function. And there's a slight difference, which we'll pick up later, between an argument and a parameter. You've seen input. So we've seen this pattern where we have a descriptor or a name and then a couple of brackets and something goes inside. The difference here is that Python's already written that function definition for us, so we don't need to. We can just call the function, put it into our code and make use of it. So let's write a function. Here's our first function. So like our first program was hello world, our first function is also going to be hello world. So in that header at the top, I've got def, my function name is hello world, and I have a blank space there in which to put any parameters. So in this case, I'm not sending any parameters, the simplest types of functions you wouldn't. So that's blank. I've got my semicolon, and then everything inside this indentation is within my function. So all I'm going to ask my function to do is print hello world. So that section there on its own, that def, hello world and print, doesn't do anything. That's me just defining. And all I'm saying is, every time you see me write hello world with brackets like this, I want you to do whatever is inside here. So underneath, I've called the function. So by calling it, you're writing the function name, brackets, plus any parameters required. So I've called hello function. What happens is I get hello world in the console. So my program has said, yep, we have a definition for hello world. Let me go and look at it. Takes a look. Oh, it wants me to print out hello world. Done. And then we'll carry on with whatever code exists underneath here. So what if I want to put something inside those brackets? So I've got my function definition, I'm specifying what I want my function to do. And in the previous example, we didn't have anything in here. But here I have num1 and num2. So in this function, I'm defining a function called sum. I'm giving it 2 parameters. Those 2 parameters, num1 and num2, I'm going to use within my function. So I'm creating another variable called temp, that's in temporary. I'm giving it num1 and num2, adding them together, and then I'm going to print that out. So note that because I've got a number here, I'm just printing it out as a string, just for consistency. So I've got function header with 2 parameters. These here, when I call it, I give it 2 numbers. I give it 5 and 7. Those are called arguments. So whatever goes into the function definition are parameters. Whatever goes into the function when I call it, they are arguments. They are the value that goes in. So what will I get here? I'm giving it 5 and 2. So this will say num1 is 5, because that's the first one in the list. Then num2 will be 2. So my temp value is 5 plus 2, which is 7. And when I print that out, that's what I get. So to make things more interesting then, I have a return value this time. So previously I've just been returning none and moving on with the rest of the code. Now I'm returning that temp value. So I have temp is 5 plus 2, and I'm going to return the temp. But where does the temp go? So it goes into, it replaces the function which is put into total. So in this case I have total becomes the value of this function. So I go and find my function definition, sum. I get my value, 7, and then I return it into the value, into total. And then I can print out total this time. So I get the same outcome. I still get 7 into the console, but I've this time returned it into a variable within the main program first. So this function on the left is what we saw in the previous slide, and you can see that I've used a temp variable, a temporary variable, to store my calculation and then return it. What I want to do is just iterate a slightly simpler way of doing that, where I can ask something to return, and then inside brackets I can put like a calculation, I can concatenate strings together, I can do whatever I want to inside these brackets, and the outcome of that is what will be returned. So whenever the sum is called, num1 is 5, num2 is 2, so return whatever 5 plus 2 is, which is 7. Now when I'm returning it here, I'm printing out whatever is inside these 2 brackets here. So I'm printing out whatever is inside here. And then within that, I'm going to make a string out of whatever is inside that set of brackets, which is going to be 7. So I'm going to have the same outcome as I did previously. I've just used less lines to write it. Now, when you're getting used to starting writing code, having temporary values is really useful because it lets you kind of step by step go through something. It maybe makes it a bit easier for you to sketch it out on a notepad and figure out what's going on. as you become more confident, you can start to drop the temporary values and just return the calculation itself. So function calls are things that we can use over and over again. When we define a function, we do it because we're going to ask this particular piece of code to be repeated. So in this case, the piece of code that I'm asking to be repeated is whatever is inside my print square function, which is this, to print out a string value of num times num being the parameter to my function. So I've used print square function 1, 2, 3, 4, 5 times. I've given a different argument each time, 1, 2, 3, 4, 5. So what will happen is I go print square 1. What do I want to do? I want to print out a string of 1 times 1. Then I go to the next line. I'm going to print out a string of 2 times 2, which is 4. Then print out a string of 3 times 3, which is 9, etc. So I get each of the square numbers in my console. So I don't do anything other than, for my function, I want to list 5 different numbers. I could call print square with the number 1 as an argument as many times as I want. The crucial thing is that print square is defined already. Of course, if I'm doing something where I'm calling a function repeatedly, I might want to try and put it inside a loop. In this case, it lends itself very well because I want to print out the square of the numbers 1, 2, 3, 4, 5. They're nicely sequential. So in this case, I've got a for loop. So for my index in range from 1 to 6, remembering that we start at 1 and we end at the 1 before our end number. So that means I'm going to calculate the squares of 1, 2, 3, 4, and 5. So again, same thing. I'm calling print square. I'm using the function print square over and over again, but with a different number in each time. Now, any variable within a function where we had that temporary variable that we've created or a function that exists within, we can only see that variable within the function. So this is called scoping. And this is why we have the semicolon on the end here. So it means that everything inside here can only be seen or used within that function. So in this case, what do I have? I have a function that I've defined here for y. I've got print y. So then I'm going to call the function, I'm going to give it the argument 10. So what am I expecting it to do? I'm expecting it to print 10. Then I'm going to ask it to print y. So let's see what our issue with that is. So when I print f, my function 10, I go up here, I say, yep, put 10 into the function, print 10, that's what appears in the console. When I go down here and I say print y, although y has been defined inside the function, I've created a variable space and I've put 10 in, what I will get when I get to the print y line here is I'll get an error. And I'll be told y is not defined in the main program. And that makes perfect sense, right? Because y is something that exists only within the scope of the function. So imagine that anything inside a function is a black box. You can't see inside it. All you can do is put numbers in and get numbers out. You can't interact with any of the component parts within the function. All you can do is, if you want to, you have to return them to the main program to do that. The opposite, though, is true. Code inside a function can see out. So if you think of it as like a one-way mirror. So code inside the function can use code from the main program. It can see those variables, it can see those values, it can make use of them. But then your main code can't use anything from inside the variable. So anything that's defined outside of a function, just like in the main code, is called a global variable. And a global variable is accessible from everywhere within your code. So in this case, I've got two global variables. I've got one called increment and one called global var. So both of these can be manipulated, changed, or accessed by any piece of code in the entire program, including within your functions. So I've got here a function called f, and there's no arguments. But what that function is doing is it's returning a sum. It's returning increment plus global var. So it figures out that increment is 50, global var is 100, adds them together, so it's returning the value here of 150, and so the value of global var is now 150. So when I print global var, which has now been manipulated by code within a function, it shows 150 in the console. So we can see that global variables are very valuable because they're so easily accessed, but they carry a bit of risk because you can change something inside a function. It can take some time to figure out where you've done that. You might not have meant to change it. Security-wise, it's not the best idea. But in terms of convenience, it's obviously very useful.